Hello students, welcome back. In today's session, we'll try to take one more result. Let's get started. The question is del square r power of n is equals to n into n plus 1 into r power of n minus of 2. So we need to prove this result. And for that, let us try to take the left-hand side and arrive at the right-hand side. So let us start with the left-hand side. LHS is equals to this del square r power of n. But first we need to get this del square value. What exactly is this del square? So we know the value of del. The value of del is nothing but dou by dou x of I plus dou by dou y of j plus dou by dou z of k. Now if you want to take this del square can be written as del dot del. So which is nothing but del represents dou by dou x of I plus dou by dou y of j plus dou by dou z of k. Then the dot product with this one more del, dou by dou x of I plus dou by dou y of j plus dou by dou z of k. Now because this is a dot product, you have to take I dot I to be equals to 1, j dot j to be equals to 1, and k dot k to be equals to 1. So now if you try to take the first value, I dot I is 1. So you have dou by dou x of dou by dou x, which is nothing but dou square by dou x square. Similarly, j dot j will be 1. Dou by dou y of dou by dou y is nothing but dou square by dou y square plus k dot k is 1. Dou by dou z of dou by dou z will be dou square by dou z square. So we have this del square value. Now if you just try to plug in this one, del square is nothing but dou square by dou x square plus dou square by dou y square plus dou square by dou z square times of what? Times of r power of n. But if I apply this partial derivatives x, y, and z and combine that with r power of n, it becomes very lengthy. Rather, I will try to take the summation of dou square by dou x square times of r power of n. So once I'll try to take the partial derivative with respect to x and combine with r power of n, complete this one. And at the end, once I get this value, I can remove the summation and express that in terms of y and z also. So now this can further be written as dou square by dou x square can be written as dou by dou x of dou by dou x. Dou square by dou x square can be written as dou by dou x of dou by dou x of r power of n. Now let's try to differentiate this one. This r power of n partially with respect to x. So that will be nothing but summation of this dou by dou x as it is. Let us try to differentiate this one. R power of n differentiation will be n r power of n minus 1. Like d by dx of x power of n differentiation is n x power of n minus of 1. That's the basic formula we are using. Into further r differentiation with respect to x. Partial derivative of r with respect to x. Dou r by dou x. But we already seen the value of dou r by dou x in the previous video. You can just observe my previous video where I have shown you the value of dou r by dou x. As we know that r value is nothing but root of x square plus y square plus z square. If I square it, I'll be getting r square is equals to x square plus y square plus z square. If I try to differentiate this partially with respect to x, r square differentiation is 2r into dou r by dou x is equals to x square differentiation will be 2x, y square is a constant, derivative is 0, z square is a constant, derivative is equals to 0. So we have 2r dou r by dou x is equals to 2x. So we can observe that this 2 and 2 will cancel out, and then further you can rewrite this as dou r by dou x is equals to x as it is. Cross multiply that r will come to the denominator. So hence, we have got the value of dou r by dou x to be equals to x by r. That value you can plug in here. So therefore, we get summation of dou by dou x of n r power of n minus of 1 into x by r. Or further, if you try to simplify this one, it is summation of dou by dou x of n r power of n minus 1 as it is. Now this r which is there in the denominator, it represents r power of 1. If I take r power of 1 from the denominator to the numerator, it becomes r power of minus 1 into this x as it is. Further, let us try to simplify this one. It is summation of dou by dou x of, it is n. When the bases are the same, powers can be added. So it becomes r power of, you have n minus 1 minus 1. So n minus 1 minus 1 will become minus 2. Times of what? Times of x. Now since n is a constant, I'll take that n outside and apply this partial derivative for r power of n minus 2 into x. Now since further the differentiation has to be done over here, I need to differentiate this r power of n minus of 2 and x. So because it is a product, I'll try to use the product rule, u into v. So we know the product rule, d by dx of u into v, it is uv dash plus vu dash. Let's try to use this product rule. So this will be equals to n as it is summation of, I'm trying to use the product rule, u. So u value is r power of n minus of 2. U into v dash. V dash means differentiation of x with respect to x. Partial derivative will be 1. Plus v. V value over here is x into u dash. That means differentiation of r power of n minus 2. So it is nothing but n minus 2 into r power of n minus 2 minus 1. Just using this basic formula of d by dx of x power of n is nothing but n x power of n minus of 1. So here n is nothing but your n minus 2. So n into, that is n minus 2 into r power of n minus 1. So n value is n minus 2 minus 1 into the derivative of r. So first power differentiation is over. Now differentiation of r. Derivative of r with respect to x, partial derivative is dou r by dou x. Right? So it is v into u dash. Let us further simplify. It is n into, it is summation of r power of n minus 2 into 1 will be r power of n minus of 2 plus keeping this x as it is, then n minus 2 as it is, r power of n minus 2 minus 1 will become minus 3. And we have seen the value of dou r by dou x is what? X by r. So it is x by r. Let us further simplify this one. This will be nothing but n into summation of r power of n minus of 2 plus, it is over here you have x and x. So x into x will become x square. So first I'll write n minus 2. Then I'll write x into x will become x square into, this is r power of n minus of 3. This denominator r power of 1, when it comes to the numerator, it becomes r power of minus of 1. Or further, if you try to simplify, it is n into, it is summation of r power of n minus of 2 plus, this is n minus of 2 into x square into r power of, here bases are the same, powers can be added. So n minus 3 and here minus 1. So let us further simplify this one. You have n into the summation of r power of n minus of 2 plus n minus of 2 into, this is x square into r power of n minus 3 minus 1 will become minus 4. Now this simplification is complete. Now you can expand this for y and z. So this expression is only for dou square by dou x square I have taken here. Can you observe over here? Only for this I have put the summation I have taken. But that has to be expanded for y and z also. So let us write down the term, remove the summation. So this complete expression corresponds to with respect to x. Now I have to repeat the same thing with respect to y and with respect to z. So let us try to see how to write down. So this n, the constant as it is. Now under the summation, I'll write down the value as it is. Exactly the same. Now same two terms, there are two terms over here. The same two terms you have to repeat for y. Now if you want to repeat for y, everything will be the same. Only in place of this x square, I'll be getting y square. So this is r power of n minus of 2 plus n minus of 2 into y square into r power of n minus of 4 plus. Again, you have to repeat the same two terms. Now for z, r power of n minus of 2 plus n minus of 2 into. Now in place of this y, it becomes z square into r power of n minus of 4. Now further, if you try to simplify, it is n times of. So if you try to observe, you're having r power of n minus 2, r power of n minus 2, r power of n minus 2. How many times you have? 3 times, right? So therefore, we'll be getting 3 times of r power of n minus of 2 plus. Further, if you try to see these terms, can you see over here n minus 2 into r power of n minus 4? This is common. Over here, n minus 2 into r power of n minus 4 is common. Here, n minus 2 into r power of n minus 4 is common. So let's take it as common. N minus 2 into r power of n minus 4 is common. If you take common, what is left out here? X square plus what is left out here? Y square plus what is left out here? Z square. So what is this x square plus y square plus z square? Its value will be nothing but r square. Can you observe over here? X square plus y square plus z square. Its value is what? R square. So I can replace that by r square over here. So therefore we have n into, it is 3 r power of n minus of 2 plus n minus of 2 into r power of n minus of 4. This becomes r square. Or further, if you try to simplify, n into 3 r power of n minus of 2 plus n minus of 2. Once again, bases are the same. Powers can be added. R power of n minus 4 and this power is plus 2. Or further, let us try to simplify. This will be nothing but n into, it is 3 r power of n minus of 2 plus, this is n minus of 2 into r power of n. Here you are having minus 4 plus 2. Minus 4 plus 2 will be minus 2. If you further try to observe here, r power of n minus 2 is common. So let us remove common. N into r power of n minus of 2 is common. So here you are left out with only 3 because r power of n minus 2 is taken common outside. Plus here only n minus 2 will be left out because r power of n minus of 2 is taken outside. Or further, if you try to simplify, it is n r power of n minus of 2 into n as it is 3 minus of 2 will become plus 1. Or further, if you try to simplify this one, you have n into n plus 1 into r power of n minus of 2, which is nothing but the RHS. So hence, your LHS was del square r power of n is equals to your RHS is n into n plus 1 into r power of n minus of 2. So that's the required solution. I hope you got this result. Try to practice it 2 to 3 times so that you become perfect with this result. So that's all I have for today. Thank you.